All right, let's talk about orchestrating data in the cloud. If you're working in Azure, you've probably heard of Azure Data Factory, or ADF. Today, we're going to break down exactly how you can use it to build some seriously powerful and automated data workflows right from the ground up.
So here's our game plan. We'll kick things off with the absolute basics, the building blocks. Then we'll explore the different types of tools you have in your toolkit. After that, we'll see how to combine them into smart patterns, get into some advanced dynamic techniques, and wrap up with transforming data on the fly. Ready? Let's dive in. You know, the real challenge with data these days isn't just moving a file from point A to point B. It's more like conducting a whole orchestra of different, complex tasks, all at a massive scale. Getting that right is tough, and that's exactly the problem Azure Data Factory was built to solve.
Okay, first things first. To really get a grip on ADF, you've got to understand its two most fundamental components. Everything, and I mean everything, you build an ADF is made from these two things: pipelines and activities. So what's a pipeline? The easiest way to think about it is like a master recipe for your entire data job. It's the whole set of instructions from start to finish that takes your raw ingredients, your data, and turns it into something useful.
Right, and if the pipeline is the whole recipe, then an activity is just one single step in that recipe. You know, like preheat the oven, or in our case, copy this data, or run that script. You string these individual actions together inside your pipeline, and that's how you get the job done.
Now, not all activities are created equal. ADF actually puts them into 4 main categories. And honestly, knowing these is like knowing what all the tools in your toolkit do. It's absolutely key to unlocking what's really possible.
So here they are, the big 4. You've got external compute, which is all about telling other Azure services what to do. Then internal activities, this is the stuff ADF does all by itself. Next up, iteration and conditional activities. This is where you add the brains and the logic. And finally, web activities, for talking to pretty much any REST API out there.
Let's break this down a bit more. The most important distinction here is between external and internal. With external compute, think of ADF as a manager. It tells a service like Databricks, hey, run this job for me. But with internal activities, like a simple copy data, ADF rolls up its own sleeves and does the heavy lifting. You add in that control flow logic, plus the ability to connect to anything with an API, and you've got a seriously powerful setup. Okay, so we have our building blocks. Now, how do we put them together effectively? It's all about using patterns. And trust me, using the right structure is a game changer. It makes your workflows efficient and way, way easier to maintain. Let's start with the simplest one, the linear pipeline. And yeah, it's exactly what it sounds like. It's a straight line. Activity 1 finishes, then activity 2 kicks off, and so on. It's super straightforward and absolutely perfect for simple, self-contained processes. But what happens when things get a little more complicated? Well, that's where the parent-child pattern comes in. Here, a parent pipeline's main job is to call another separate child pipeline. This is a fantastic way to break up a massive process into smaller, more manageable, and reusable chunks. So why bother with this? 2 huge reasons. First, it makes your error handling so much simpler. If that child pipeline fails for any reason, the parent can catch it with just one single step. And second, you get way better control. The parent can literally just wait for the child to finish its work before it moves on. Now let's take that pattern and put it on steroids. This is the iterative parent-child model, and this is where ADF gets really smart. The parent pipeline first looks up a list of things to do. Let's say a list of tables to copy from a database. Then it just loops through that list and runs that same child pipeline for every single item. This right here, this is the secret sauce for building scalable, meta-driven workflows. That whole idea of being metadata-driven is a perfect transition to our next topic, making pipelines that aren't hard-coded. We want to build pipelines that can adapt on their own when the data changes, without a developer having to go in and rewrite them every single time. So let's talk about a classic headache for any data engineer, schema drift. You know the drill, right? You build a pipeline to copy a table with 10 columns. What happens when, out of nowhere, the source system adds an 11th column? A static pipeline would just break. We need a way to handle that automatically. And the answer is dynamic column mappings. See, instead of clicking around in the UI to hard code the mappings, you can just pass in this JSON object as a parameter. It tells the copy activity how to map columns on the fly, at runtime. And even better, you can generate this JSON from a metadata base, which means your pipeline can just automatically adapt to those schema changes. No more broken pipelines.
Partitioning is another one of these super powerful techniques. When you're writing to a data lake, you can tell ADF to automatically organize the data into folders based on a column's value. You could, for instance, create a separate folder for each year of sales data. This massively speeds up your queries later because you only have to read the folders you actually care about.
So far, we've mostly been talking about an ELT, extract, load, transform approach. Where you move the data first and then transform it later. But what if you need to do that transformation in flight? Well, that brings us to mapping data flows. And this is a really crucial question. How do you clean up messy data, join different sources, or calculate aggregates during the copy process without having to write a whole bunch of external code? The answer is mapping data flows. This is a graphical, low-code interface where you can build some seriously powerful transformation logic. You just visually design the flow, and ADF handles running it on scalable clusters that it manages for you. It's basically like getting all the power of Spark, but without all the complexity. And the kinds of transformations you can do here are incredible. You can join data sources, create new columns with complex calculations, filter out bad records, even handle updates and deletes. It is a full-blown data transformation engine right inside your pipeline. Okay, let's recap the key takeaways here. Pipelines orchestrate the entire workflow. Activities are the individual steps, and they come in 4 main types. And the real magic happens when you combine those activities into smart patterns to build efficient, reusable solutions. Hey, if this explainer helped demystify Azure Data Factory for you, please do us a huge favor and hit that like, share, and subscribe button. It really helps us create more content that makes this kind of complex tech easy to understand. We've covered the blocks, the tools, and the patterns. The foundation is all yours now. So the question is, what's the first data workflow you're going to build? Thanks for watching.